Okay guys, so we are moving into the portion of our unit on univariate data where we represent the data. You may have seen dot plots in 6th grade, so we're just going to do a quick review of what they are. So if you look at the top, a dot plot consists of a horizontal scale, a number line, on which dots are placed to show the numerical values of each data. If a data value repeats, the dots are piled up at that location, one dot for each repetition. So we're asked to create a dot plot for the following data. It compares different families and the number of TVs they have in their home. So over here we're going to make a number line, and to do that we want to look at the list and see what the smallest value in the list is, so that would be 0. And what the highest value is, that would be 4. So on our number line, we're going to make a number line going from our lowest point, our minimum point, to our maximum point. And then we're going to give each family, each data point, a dot to represent their data. So we are going to go ahead and we're going to plot a dot for the Adams, and I like to check them off as I go, representing that they have 1 TV. The Bakers have 0. Cox family has 3. Davis has 2. And I like to do the best that I can to keep the dots in line, going horizontally and vertically. So like you can see, I'm trying to keep the 1 in line with the 2 column, just so that I can really see the shape of this data. That's the whole point of making these data representations, is to view the shape. Okay, so that is our data representation. And so if we go ahead and calculate the mean, median, and mode, obviously the easiest one to see right away is the mode. And so if I count how many families there was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so since there's 11 families, I know that the middle person is going to be person 6, because person 6 is going to have 5 dots below them and 5 dots above them. So to find the median, I'm just going to count 1, 2, 3, 4, 5, 6. So the middle of my data is 2. The range is also pretty easy to see, since we know that the minimum is 0 and the maximum is 4. So obviously our range is 4. And then again, a dot plot is really nice because we can easily see how many people are in each category, or how many data points are in each category. So if I want to calculate the mean, I can easily see, okay, I have 2 people in column 1, so that's going to add up to 2. I have 1, 2, 3, 4, 5 people in column 2, so that's going to add up to 10. I have 1, 2, 3 in column 3, so that's going to add up to 6. And I have 1 person in column 4. So I can kind of easily add these numbers up. A little bit easier than having to take my calculator and just literally punch in 1 plus 0 plus 3 plus 2. So if we do that, we get 22, which we divide by 11. So the mean of this data is also 2. So pretty consistent data there. So what are the advantages of seeing data represented in a dot plot versus a list or a table? Well, as you can see, the list in the table is not very organized. So it's an organized way to view the data. We can easily see the shape of the data. Easily see the shape of the data, which we're going to talk a lot about, because the shape we have specifically here is symmetrical, because you could fold the data in half and it folds kind of pretty much perfectly. So this data is specifically symmetrical. We're going to talk about some other kinds of shapes that we can get. We can easily calculate, as I was kind of talking you through, the measures of center and spread. And so as you can see, there's a lot of advantages of seeing the data in a dot plot as opposed to a list. We also have what are called double dot plots, and as it says at the top, they're useful when we're comparing two sets of data that measure the same variable. So the example we have are of the Hall and Conard baseball teams and how many points they scored in 10 games. So the double dot plot is going to make it really easy to kind of compare the performances of the two teams. So again, we're going to take a look at both lists now and try to find the minimum and the maximum. So the minimum, the smallest value I see is 0 in both lists, and the highest value I see in both lists is 9. So on my number line, I'm going to start at 0, and I'm going to go all the way up to 9. And so I'm going to do the Hall dot plot the same exact way that I did the last dot plot, giving a dot for each data value. And you do want to label this side as being the Hall side, just so we know. So again, I'm crossing off as I go. So I do 4, 4, 2 6s, 8, 2 3s, 2, and 2 1s. Good. And so now I'm going to do the Conard baseball team on the bottom, the bottom of my number line. So I'm going to do the same thing, but just putting my dots underneath the number line. Again, crossing them off as I go, just so I don't lose track. Got 2 5s. 2 1s, I've got a 2 and a 0. Okay, so now we have a data representation that represents two different sets of data measuring the same variable. So we can easily compare Hall's performance to Conard's. One thing I want to point out, even though, like for instance, Hall didn't score 5 points in any game, I still left a space open, okay? So even if you don't have a data value at the number, you should still leave it open. So I shouldn't have jumped from 4 to 6. And just because 7 didn't have any data points, I should still have that point there to show the gap in the data. So I want to be able to see that there's nothing in 7. So which team has a greater median? Well, again, they told me that 10 teams played. So my median is going to be between the 5th person and the 6th person. So let's count for Hall. 1, 2, 3, 4, 5. So my median is in between 3 and 4. So Hall's median is 3.5. And if I do the same thing, 1, 2, 3, 4, 5, Conard's median is between 2 and 4, so their median is going to be 3. So the team with the greater median is Hall. The team with the higher maximum value is Conard. Their maximum value was 9. Hall's was 8. And the team with the greater range is also going to be Conard because their range is 9, whereas Hall's is only 7. So if we think about it, we can easily look and see that obviously Hall is more compact, right? They go from 1 to 8. So they're a little bit more compact, they're a little bit more consistent. Conard, on the other hand, is a little bit more spread out. So Conard will likely have a greater standard deviation because they are more spread out. On the bottom of this page, they ask you to list conclusions that you can make about the two teams. I want you to fill out that question on your own. So I'll be checking that tomorrow with these notes as well.